All right, I think we can begin, and those who enter later can hopefully jump in as they see fit. So, welcome everyone to this session. Today, we're going to talk about a real case journey from the .NET Framework to .NET Core, which I've been part of during 2020. We've been a team of developers migrating a large enterprise application at one of our clients for a full year, actually. We just finished that migration to the core, and I've personally learned a lot of cool stuff during that migration, and things I definitely want to share with everyone here as well today. I definitely want this to be very interactive. I'm super happy that this format works so well that you can both unmute and talk to me or add something in the chat, what have you. So if there's anything you want to talk about or discuss or stop me, please don't hesitate to do so. I'm going to move over the chat to my other screen and open up the messages here. So in case you have some messages, I hopefully will see it. And if I don't, you can just kind of unmute and talk to me. That's fine. Cool. And I hope you get something fun out of this, really. So that's my goal today. But to start off with, who am I? My name is Alexander Slotte. I am based out of Washington, D.C., so not too far away from Philly. And I've been a speaker at Phil.net a couple of years now. Did not speak in the fall, but I believe I spoke probably like a year ago or something like that. It's a great conference. I love speaking here. I'm a Microsoft MVP in developer technologies, and primarily on my spare time outside of my client work, I focus mostly on machine learning and ML ops. I love ML.net. I speak a lot about it. I created a conference on that runs twice a year. And I also have an open source tool called mlops.net, which kind of simplifies the DevOps process for machine learning algorithms. So that's my kind of quirky interest outside of my client work. So if you ever see me around, that's probably what I'll speak about. If you're more into the MLOps, I will talk about that tomorrow, but that's not the topic of today. Following this, if you find what I'm saying interested, if you learn something, or if you want me to have another look at your applications, I am actually happy to do a free technical exploration of your applications. Happy to have a look at how much effort it would take to migrate into .NET Core, and also assess what things would need to be refactored or re-architected for it to work. So definitely contact me if you're interested to learn more about that. You can find me on Twitter, or you can find me at alexander.slotte@excella.com. All right, but today we're going to talk about a journey. And I've structured this in kind of 3 different phases here. In the first phase, just quickly, I want us to zoom into the application that we're migrating. And I want to look at the organization that I worked for to understand kind of their constraints they have and their processes, because that is really important when you migrate an application as well, to understand your constraints, which will definitely set some of the goals, things you can and cannot do. We'll then spend a lot of time looking at the journey, of course, how we did it, why we did it like we did, and what things we kind of ran into that were issues that you should look at. And what I try to do today is both structure it with like general information, this is how you do it, as well as information about, okay, well, we figured this out and this didn't really work so well for us, but this worked really well for us. And hopefully that'll be something you can use when you try this yourself. And then finally, we can look at lessons learned through this journey. And I want to open up for a larger questions and answers session for anything you may wonder about. I hope that looks good to you all. So first of all, let's look at the application that we're migrating to .NET Core. So it's a standard .NET Framework app. It's originally was based on .NET Framework 4.6.2, and the green part of this diagram is the application itself, and the blue part is everything is interacting with. So as you can see, it's a highly kind of connected application. I don't think I even included everything here on this diagram, really. I just wanted to give you an overview of what's going on. But basically, it has tons of package dependencies, and they're all outdated. It's a 20 project or so application. It's very standard .NET Framework API application with anti-framework as the ORM. The UI is an AngularJS Knockout.js frontend, so we don't use any Razor, we don't use any web forms in this case, but we just use a plain UI layer that connects to the API below. We have tons of other apps that connect to us. So we interact with BizTalk both through WCF services as well as RESTful APIs. We have queue mechanism. We both look at queues and we put messages into queues. We also have other applications that call us directly on our API, or they call us through some kind of glue app that will then call us through a Node.js app or something like that. So the details are not so important here, but I want you to kind of appreciate that this is it's a complicated application in a way that a lot of other consuming application depends on it. So it can't go down during a long period of time. It needs to be up all of the time here. If you then switch over looking at the organization that this application was working for, it is kind of a classic organization, as you will find in many places. It is agile in a bubble, as I would say. The team is very agile. We have our 2-week sprints with monthly releases in our case. We have all the regular agile ceremonies, if you will, but the organization itself is very waterfall. They have multi-year projects that cannot be delayed, that have a large product plan, and we just have features kind of that boil down into our backlog based on those projects. But we have very little decision power on when to do things and how to do them. Despite the app being an internal app, they're highly risk adverse, so they do not want any bugs in production. And this is because this is a financial application. So that really puts some just general constraints on how we're going to do this. And of course, you don't want bugs in production in general, but in our case, we want to be really sure that things we are changing in the application doesn't break anything existing. They have a culture of not staying up with the latest, which means that all dependencies are more or less outdated. But a good thing is that they have very mature automated QA practices, so they have a lot of good test coverage. And the team itself is consistent of 15 to 20 or so business developers and QA. So we have a really good, solid team overall that has helped us with this. So when we wanted to do this, we had to really get the buy-in from an organization. And this is something you will also have to do when you want to migrate an app to the core. It may seem obvious that, of course, we want to migrate to that core, we're going to get all this awesome stuff. But the organization may not want to do that if you don't present a good business case. In fact, we have multiple attempts to getting buy-in over the years, and we failed multiple times doing that. But I would say that the release of .NET Core 3.1 about a year ago or so really helped that, because that gave the long-term support that was needed. It kind of stabilized the .NET Core platform, and it opened up a lot of features that we required to do the migration. So I would say that's a really good starting point. And now with .NET 5, of course, that's an even easier sell. But things we pushed for were things that, you get updated dependencies, you get security patches, you get an awesome improved performance. And we actually seen about a 30% improvement without any other changes. But foremost here, you get an extended expected lifetime of the application. So you can say that, hey, if we do this, your application will probably live 5 or so many more years than it would otherwise, which is always a good thing if you're looking at a financial investment. For us, we are an on-premise application. We are running in IaaS, so we are not yet in containers or in the cloud, but that's definitely something that they want to go towards. So going to that core as well is going to prepare you for that. So that's something you can also mention to the leadership team. So how do we want to do this? What were our initial strategy that we set out before getting into the details here? Well, we wanted this to be experimental and incremental. We do not want a lot of upfront planning on what to do and how to do it, because we realized really quickly that we were doing nothing. We started analyzing everything. We started reading up on that core, reading up on dependencies and how things worked, and we just got no traction whatsoever. So we want to adopt more of an experimental approach. We change things quickly and relied on our tests. We were forced to deliver new features to the business, so we could not have a kind of feature freeze and just the whole development team working on this. We actually had to do this at the same time as we were also delivering features to the business. And a colleague of mine gave a really good analogy on this. We were basically a car that transformed to a boat while we were still putting on a sail at the same time. And that definitely caused a lot of kind of challenges that we had to overcome in one way or another. Another thing we tried to do was to avoid a long-running branch, and that's something I will return to during this talk, and that's something you definitely want to avoid at all cost. A long-running branch while migrating to .NET Core is going to be very troublesome for you, and it's going to be very dangerous. So try to avoid that if you can. And if you can, try to dedicate about 15 to 20% of your sprint time to this migration effort continuously, if possible. The key success factors for us, if you look kind of back the whole year here, and this is something that worked for us really well, and I think works for most teams as well. And if you don't have these factors, it's something you probably want to look into before you start migrating to .NET Core for an enterprise application. So we had a very robust kind of automated QA practices. We were already doing TDD, and we were doing behavioral-driven design as well with Gherkin syntax and spec flow. So we had a really good coverage of our application as a whole. So if anything broke anywhere, we most of the time at least found that through our CI/CD pipelines, which was very, very helpful. If you don't have a really good coverage of automated tests, I recommend that you start by adding functional tests to your application. Don't worry so much about unit tests when it comes to this migration, but focus on the functional test from the UI or from the API layer. That will catch most of the things you'll run into. The third thing here I really want to highlight is that you need to have a fearless approach to cleaning up all technical debt. And that can sound scary, because it was for us, but there are so much crap in an old .NET Framework app that you just need to get rid of, and you need to dare to get rid of it. For example, in your CS project files or solution files, there may be a lot of definitions and attributes and what have you that you don't need at all, and they just have been there forever, and you do not want to migrate those to any other solution. You do not want to refactor them. Most of the time, they're probably not used at all, or you can find a much easier solution than what's currently there. So be a little bit fearless and rely on your test automation to find things. All right, so diving into section 2 here, what was our journey? How do we go from .NET Framework to .NET Core? The first thing I started out with, and I recommend everyone doing, is reading the Microsoft docs. There are 2 documentations here that you can look at. There's one general for .NET Framework to .NET Core, and there's also one specific for ASP.NET to ASP.NET Core. They're both good. They're great, honestly, but they are 7 minutes reads, and they are not comprehensive because every application is very unique and different, and they can't cover everything in the docs. But it's an awesome starting point, so I recommend that you look at that first to get a good idea what you need to do. I also recommend that you do not rely on the portability analyzer. So one of the steps that you will do very early according to the docs is that you will download a portability analyzer and you will run it on your app, and that will spit out an Excel file with about 1,000 or so lines saying what work namespaces and what classes are incompatible with .NET Standard and .NET Core. To me, that was not very helpful because they're not necessarily grouped into bigger groups of what packages are incompatible. They don't really tell you what's wrong, and it's really easy to get overwhelmed. So for us, that approach didn't really work, and I think that is causing more lack of starting than anything else. I would recommend you don't really think about that too much and just follow the recommended steps apart from that. Just a tip here. Excuse me. So what did we do? Well, we followed these 5 steps, more or less, that we're going to dive into more into detail now. And the first one was targeting .NET 4.7.2. We then migrated our configuration schema. We updated our dependencies. We spent a lot of time porting our web app, and we updated our CI/CD pipelines and tools. What we did not do, and I'm not including in this talk because it was not applicable to our app, is that we did not migrate web forms. And I'm mentioning that because web forms has its own challenges, as you may be aware of. And there are tons of good recommendations how to do that that you can look up online, but we did not include it in our app. Neither did we host any WCF services. We consumed WCF services as a whole, which works just fine, but we did not host any services, which is going to be an issue overall. So if you host WCF services, what you need to do instead is considering migrating to gRPC instead, or something like that, as a solution. So we'll not discuss that today, but I know there are solutions for both of them. So let's dive into the first one here, which is targeting .NET 4.7.2. And why do you want to do that, and what is it all about? Well, firstly, the reason why you want to go to 4.7.2, for example, we were on 4.6.2, is that 4.7.2 shares the same API as .NET Standard 2.0. Sorry, .NET Core 3.1 and .NET 4.7.2, they both share the .NET Standard 2.0 API. So they share a lot of commonalities, which is very helpful when you migrate things, because they're going to be very similar. So if you get there first, you can then do some other stuff that makes it easier to switch to the .NET Core. Once you are on .NET 4.7.2, things you want to do as well as part of that is to migrate to package references. So the normal standard way of doing package dependencies, like NuGet dependencies in that framework, right, is package.config. But the new way of doing it is in the package, is in the project file, and you want to do that as package references. And this can actually be done automatically through a tool in Visual Studio. So this is actually a very simple process to do. The final thing you need to do, that you can either do manually or automated, we did it manually, is to convert to an SDK project style. So the new project style is very different than the old one, in the sense that it's not 1,000 lines long if you have a large project. You do not need to define every class that you are including in your project anymore. It's enough just to kind of, by default, I would say, to include everything in the directory of that project, which is very helpful. And that's really good and great. For our case here, when we converted to an SDK project style, we started having compilation issues and all kinds of stuff. And the reason was because it's including every file in the directory, and not only files that you define yourselves. For us, that included a lot of dead code, old code, things that hadn't been removed from Git before. So a lot of technical debt that we resurfaced. So that's just something to keep in mind when you do that you want to do that. Especially when you look at test projects. You may suddenly start running more tests than you did before, because you have test files that were not included in part of the CS project file. And I think you all kind of have, that when it happens, right? When you, in the framework, you add a new file and you commit that file to Git or TFS, but you forgot to change or commit the project file itself. And you will see a lot of these use cases when you convert to an SDK project style. So basically what we're doing is we're going away from this package.config here that is ugly, where you define the package dependencies and the version and the target framework. And you go more to this SDK product style, where you have the package references that you define right here. And then everything else is kind of more consolidated in many ways. You have your project references and your target framework and everything else in a much more readable format. You know it's an SDK product style because of the top annotation here. Cool. Any questions so far on the first segment here, or is that crystal clear? That is probably the easiest part of the whole journey. All right. So the second part here is probably debatable, but we went ahead and did this first, which is migrating our configuration schema. And this is something that, at least when I started doing this, was not something I thought of I needed to do, or was something I kind of just forgot in many ways. But when you look at the old way we did configurations and the new way, they are very different. Configuration values used to be in the web.config, right? And you had app settings segment, and you had a connection string segment, and so forth, and you defined everything in XML. And you happen to have your transforms like a web.test.config and so forth, and you used Cheetah or MS-Build to do your transformations for you. In the .NET Core, you instead have your app settings.json files, and you can have overloads if you want to in the same fashion as you see at your right. But they are in JSON format, and more importantly, they have segments or sections. So we have a features section here, and we have keys for each of these, keys for this section, which is enable feature 1, enable feature 2. So at first, it could be easy to say, well, that's fine. We'll just convert our XML to JSON, easy peasy. There's actually tools that do that for you out there. Andrew Locke has a fantastic tool that I recommend. We use that for that. But you also need to do things in your code to make this work as well. So what you usually do in the .NET framework is that you use the configuration manager. So the system.configuration, the configuration manager to read config values. And you may do that across the application, or you may have a centralized configuration reader or something like that to read those. But when we move to .NET Core, we instead need to use an iConfiguration, which exists in the Microsoft.extensions.configuration namespace, which is a NuGet package. So we need to refactor all of our code to rip out the old way of reading configurations to include a new way of doing it. And we also need to wire up how we read the configuration values. And if you want to do this incrementally over time, the best way of doing that is installing the NuGet package you need, and then start replacing iConfiguration manager with iConfiguration that you inject into your classes where you need it. What you can then do is create a custom provider to read config values, and we'll look at how that can look at in the next slide. But basically what you want to do here is you want to read the web configs values, and you also want to read the app.json for a period of time, so you can incrementally migrate over your values. The reason why we did this is because we had like 300 config values, and they were scattered all over the place, and they were not consolidated. So we took the opportunity here to do some technical depth cleanup, refactor some of the config values, clean them up, organize them into nice sections, and so forth, which was really helpful during this phase of our migration. But once you have your provider that reads both the web config and app.json, what you can do then is start doing that migration to the JSON format. And again, you can do this in automatic fashion, or you can move them over manually, one by one. And a custom provider can look something like this. So if you are familiar with the .NET Core configuration provider, what you generally do is you have a configuration builder, and then you add a JSON configuration reader, and maybe you add an overload for app settings.connection strings or connection strings.json. But what you can do here, what we are doing, is we're adding a legacy configuration provider, which is a custom provider that we have created ourselves. And this one reads the web config. So if you add that first, and then you add a provider to read the app.json, you can read both of those at the same time. So you can have them in parallel if you want to slowly, incrementally move over. And if you want to know exactly how this is done, I have a blog post on my website, alexander.slotte.com, that I kind of lay out exactly how you can do this for the configuration itself. So I hope that made sense. I know that was a bit quick on the configuration, but that took us probably 2 months to migrate out from the web.config to app.json. So it was quite a big undertaking. And for us as well, we had to update our deployments and CI/CD tools, because when you add sections, you will need to include a section and a colon, and then the key value as the kind of value for your configuration value to locate it in deployments. So we had to update in many places, and took quite a bit of time to do that. So the next thing here is the dependency updates. And this is probably the second largest undertaking. The biggest undertaking is porting the web app, but the second largest one is dependency updates. And this is going to take quite a bit of time depending on how large your app is and how complicated it is. But basically what you want to do here is you want to update all of your NuGet packages to target .NET Standard 2.0. So if you have old packages like we had AutoMapper 3.0 when we did this, that AutoMapper version will only target the .NET Framework. It will not target the .NET Standard. So that by itself, was an issue, because we needed our dependencies to run on .NET Standard so it can run on .NET Core. So what you have to do first is go through all your packages and retarget them, or upgrade all dependencies to a version that includes .NET Standard 2.0. And you can look at that real quickly here in NuGet or in Visual Studio, and just make sure that it targets .NET Standard, and you should be good. or below. You can target on a standard 1.6, and that's fine too. It's actually even better. Be cautious here though. You need to target .NET Standard 2.0 or below. If you target .NET 2.1, it's going to be a little bit trickier for your migration, because .NET Standard 2.1 shares the API with .NET Core 3.1, but not with .NET Framework 4.7.2. So that's why it's important to have 2.0 here as the kind of common denominator, if that makes sense. The second thing here that we found was super useful is enabling multi-framework targeting, or target the standard 2.0, whichever you kind of choose. So what you can do is you can go into your new project files that are in the SDK style, and you can change the target framework attribute, or I forgot the name for that right now, tag, I guess, to target frameworks with a plural. And if you do that, you can then have a comma separated list to which this solution or this project is going to compile against, which is great. So for example, for us, we could do .NET Core 3.1 and .NET 4.7.2, and then we can decide just to build the .NET 4.7.2 project solution in our Team City setup or our CI/CD setup. So we could still like let it compile locally 3.1, even though it wasn't successful. But we can let it compile against the existing production version in our CI/CD tools. So the observant audience here could see that we can also target .NET 2.0 instead, which will be another solution here as well, and just having one framework instead of having two. And that was our initial thought as well, honestly, but that did not work for us. Does anyone on the call today on this talk here know why .NET Standard 2.0 may not work for everyone? Because it will work for some people, not everyone. The floor is open if someone wants to jump in there. Give you 10 seconds. Silence. Okay. So the reason why we could not target .NET Standard 2.0 was because of Entity Framework. So we will look at that more later, but you do not need to update .NET Framework 6.4 to EF Core when you go to .NET Core. Entity Framework 6.4 will run just fine, even though your application is on .NET Core. And that's because Entity Framework is compiled against two targets. It's compiled against .NET 4.7.2 and .NET Standard 2.1. So 2.1 is the .NET Core version, which rends itself useless for us in some ways. So if we would have targeted .NET Standard 2.0, we would have been forced to upgrade to EF Core. In our case here, we do not want to upgrade Entity Framework directly because that's a big risk by itself. So we chose instead to have a multi-framework targeting approach here. And I actually recommend everyone to hold off a little bit on the Entity Framework upgrade because it's not always needed. You definitely want to go to EF Core, but that's a very risky undertaking because it's a complete new application or tool. So I would wait with that until you are on that core completely for your application. So once you have multi-framework targeting here, what you can actually use as well is something called conditional dependencies in your project file. So as you see here in this example, I can use a condition in my project file to just include certain references for a certain framework. So for example, I can use this condition to only include a signal R, old signal R, if I'm on the framework, versus some other packages for every case or just for the core. So why was this useful for us? Well, signal R, for example, is a package that many people uses. We definitely use that in our application. But when you move to ASP.NET Core, that is no longer a standalone package. That is actually included as part of the ASP.NET Core package itself. So you can't necessarily just switch that over and upgrade to a new package and fix all of the discrepancies. You actually need to have both side by side for a period of time. And do different kind of feature toggles in the UI, and then figure out how you want to do the backend with your hubs. But the way to make sure that at least we can build all the time is by kind of toggling it off when we are on the core by including this feature toggle here. This is also very useful for me, I think, in many cases where we had multiple dependencies that we wanted to migrate over, but we wanted our application still to build in some way. So we could label them all with .NET 4.7.2 and say, hey, only do this if you're on the .NET Framework. If you're on the core, don't even include these packages because we know that this version is not compatible at this point in time. So super useful. And hand in hand with conditional dependencies is preprocessor directives. So for example, you may see this in your code sometimes where you have like a hash and then if, and you can use that to say a certain part of your code should only compile if you are on a certain framework. So for example, the .NET 4.7.2 or the core. So this is the way we kind of massaged out the old SingleR code in our app by toggling off anything that had to do with the old SingleR, all the namespaces and all the references in these toggles, and then enabling the new stuff, the new hubs, with another preprocessor directive for the .NET Core app instead. This is something I don't use lightly. I think this clutters the code a lot, but I will just kind of reiterate that this was super, super, super useful. I don't know if we could have done the migration as we did without having a feature freeze, without doing the specific, using the specific directives and the conditional dependencies. So I definitely recommend using them if you can, but just make sure you clean them up as soon as possible afterwards. All right. Any questions so far? Everyone is good? I have the chat window open as well if you have any questions.
So
Go ahead,
I have a
Jeff.
question. I take it that throughout all these migration, with that chart that you show with those green bubbles, so at any given stage, your application not only builds but also runs as before.
Correct, Jeff, exactly. So we'll go into the kind of strategy a bit later, but that's actually the strategy we had, is that we wanted to make sure the app was continuously building and deploying to production. And we want to make sure that anything we changed would still work with the old. So when we update package dependencies, we made sure to do that as part of sprint work. We had our automated test running and they passed. We had our QA team doing some quick checks here and there and just making sure that it worked. So we just upgrade application bit by bit without committing to that core. We more or less addressed all of the technical depth with all the dependency updates needed, if you will. Great question. All right. So when it comes to package dependency updates as a whole, there are a couple of gotchas that we run into quite a bit that you will also run into, and you have to think about how you want to deal with them. And the first one is that your packages may actually be reaching end of life. So they may work great for .NET Framework, but the community does not want to continue working on them in the .NET Core. So they have no support in the .NET Core, and the maintainer may have just kind of left or whatever, which is completely normal. That's just open source as it is, right? So we had that issue with our test framework, AutoMock, for example. AutoMock does not exist in the core, so we have to change our whole mocking framework for 20,000 tests to AutoFixture AutoMock. And that was a large undertaking as well, because that's a different API. Similarly, we created emails that we sent to users. We used a Razor package for that called, I think, Razor Engine. And that was also out of life or end of life. So we had to change that package to Razor Lite instead. And you will probably run into more of these cases depending on your application. So be prepared to refactor your code as it comes. The second thing I want to highlight here is that if you are really far behind in your versions, like we were, you may not only run into API changes that you will catch with a compiler, but it's very likely that you run into behavioral changes too. So for example, we had Automapper 3.0 when we started, and the latest is Automapper 10, right? And that's a large jump there, right there. And of course, we had tons of API breaking changes, but we actually realized we had changes in how Automapper worked inside as well. So suddenly it was not mapping as expected, and we had strange results everywhere, and it was pain for sure. But when it comes to this, just be cautious about that and make sure you have functional tests to capture this. Like we would never have seen this if we didn't have all our functional tests. That's really, really important to highlight. The third thing here that is just horrible, honestly, but you have to get used to it and just kind of deal with it, is assembly redirects. And I actually started every day during the last year with like the saying is, today is going to be a great day, make it a great day. Because sometimes it can be very, very disheartening with all the assembly redirects you will get. So if you're aware what that means really is that if you update a package dependency, for example, let's say we update Newtonsoft JSON, right? If you update that dependency, there may be other packages that depend on an older or a newer version of that dependency. And you may run into redirect issues where you can't load types or something, or load the wrong DLLs and other stuff. And the way to deal with that is to add redirects in your web config. And they can quickly become very long. And it's very difficult to understand always which version you need to point to and everything like that. After a while, you will figure it out and you will have like a good gut feeling on like, okay, well, this is where we have to redirect to here and there. But it can definitely be tough. So just kind of be nice, be kind to yourself when you do that, and just be prepared for that fight. All right. So at this point of time, what we had now was that we had every one of our 20 or so solutions, or sorry, projects, were running on the latest dependencies. We had them running on a multi-framework targeting, so they ran on both .NET Core 3.1 and they ran on .NET Framework. What that means that it compiled on those. And these were all class libraries. So the web app was still just the regular .NET Framework web API that you would expect. But all the dependencies it depended on were now working on both .NET Framework as well as .NET Core. So that's kind of the goal you want to get to first. Make sure all your class libraries can work on both. Make sure dependencies are updated. And then as a last step, you want to go to your web app, which is going to be the kind of the biggest change, I would say. So when you move to your web app, there's a couple of things to think about here that you will have to do. First of all, you will need to create a new project. All of your old projects, the class libraries, right? You can actually update those within themselves. You can update the project file, they can keep the same project, that was all good, change the SDK style, that's fine. You know, everything could be done within the project. But the web app is so different, so you'll need to create a new project itself to start over with. You'll need to migrate your files over to that new web app. But basically what you need to do here is you need to migrate everything you have in your regular global ASACs to something called a star.cs. And they are both similar and different in the way they works, but basically you have all your filters and your action delegates and your exception filters. All your kind of infrastructure code needs to go over to a star.cs file. You also need to migrate your controllers and namespaces. So the namespaces has changed. They will rip out the system.web namespace for you. That's no longer available. And you will also inherit from different controller classes and so forth. I would say those changes to the controllers and namespaces are very limited. They're not major in any ways. They're like 3 or 4 main things, but overall they're pretty okay. The big change will be in your global ASAC to start.cs. But when you get to this part here, avoid a long-running branch again at all costs, because you will have merge conflicts out of this world when you have to merge controllers from the old framework with the new framework, or other kind of wire-up code. So don't use a long-running branch. It's just going to be difficult. And also, we'll dive into that a bit more later, but beware of changing API. So we talked before about the API surface to your packages potentially changing, but the way that a .NET Core API behaves is very different than what a .NET Framework API behaves. You will just have a very different interaction there with like bindings and other things as well. And I will kind of show you some examples of that a bit later as well here. But when you get to this point, you need to pick a side. So before, I would always recommend that you do kind of what you did before for all your other projects. Just incrementally update them, rip out your technical depth, update dependencies, you know, all those kind of stuff. That could be done as part of feature work. I always recommend that approach. When you get to the web app, you have to pick a path forward because you have to have a new project. And of course, what you can do here is a couple of things. You can skip upgrading completely. So for example, a couple of apps that you may have in your arsenal, they may be sunsetted anyway. They may be completely rewritten, they may be small, so you may not actually want to do this at all. And we actually have one of those apps on our client that we will just rewrite from scratch in Blazor and .NET Core. So that's definitely an option. The second one, depending on your team, is a big bang here, which basically means that no feature development is going to happen. The whole team is going to just huddle around this web app, and we're going to migrate everything over and convert everything, and then as a big bang, we're going to release it to production and hope everything works. That depends on your team, right? If you have an organization that is okay with that, that's definitely an option. If you think that's the less risky approach, definitely an option. For us, that did not work at all because our client wanted us to continually deliver features as we went forward, so we could not do that. A third option is a side-by-side with redirects. So you can have an old web app and you can have a new web app, and they can be hosted side-by-side, and you can have redirects between them. So you can migrate a certain part of your application first, and then move on with the next, bit peu en peu. And you can have redirects between those parts of the application instead. And the final one that we actually went with is incrementally without redirects with a small bang. And that is very cryptic, I understand that. We'll dive into what I mean with that a bit later here. But this is definitely an approach I recommend. It worked really, really well for us. And I was just very happy with the outcome, and especially the how non-risky, I would say, that approach was, and how much we learned as we did it. But basically, if you look into the strategy of incrementally without redirects with a small bang, what that really means, that means that we have to think about our code in two different buckets. And when I say our code here, I mean our web app code. So our web app is made up of two different parts, right? It's made up of slow changing code, and then it's made up of fast changing code. And the slow changing code are things that you never change really, or change very rarely. And that's your infrastructure and piping stuff. And then you have other stuff like the controllers that change very frequently. You can't guarantee that it won't be changed within half a year, for example, because you have new features, you need a new controller method, you need a new view model, whatever, right? So what you can go ahead and do here is you can say that, okay, all of my slow changing stuff, I will do that as part of feature development. And my fast changing stuff, I will do that as a small bang, if you will, and be converted at one time. And if you look at the slow changing stuff here, that includes all of these stuff here. So for example, we have to wire up AutoFac, AutoMapper, our authorization, and our filters, Signal R, our logging, and our background jobs, right? And what we did here is that we said, okay, we'll create a template .NET Core web app. And then we'll create tickets for each of these slow changing stuff. And as part of feature work, we'll migrate them over. So in one sprint, we will look at the AutoMapper, and we will go ahead and migrate the way we wire up AutoMapper. And the next one, we'll look at authorization and make sure that we have our Windows authentication working properly in the core, and so forth and so forth. And each of these changes then can be tested by developers or QA if you want to, but it doesn't go to production. It's just a new project that we don't build in our CI/CD pipelines. It's just something that we have that we can slowly increment things over. And there are things here that we don't need to rush with because they are never changed really. Like no one's going to change authorization because that's been like that for 10 years and so forth. And this worked really well for us because without committing to the conversion, we already had something that worked really well, and we knew that AutoMapper worked, and we knew that our filters for exception handling worked, and so forth. So and that was really nice because we could also loop in developers from the whole team doing this, and they can slowly learn more and more about the core and how things were wired up and how things were different than the framework. We then had our fast changing code here, and we had a very unconventional approach to our fast changing code. So fast changing code again is controllers, view models, things that change a lot, and that we, if we move them to our new project, we will have to keep them in sync more or less in both the new and old one, which is not great. So we don't want to do that. We want to avoid that. So we want to keep them in our old projects, and we want to move them over to our new one when we need them. So what we did here is we built a custom console application here that converted the old API to the new API on demand. And it took about 5 minutes to run, more or less. And what it did was it went through all the files in the API project and it copied them over to the new project. It replaced all the namespaces that we needed. It replaced all of the annotations that were wrong. It installed package dependencies that we needed and so forth. It even converted some test projects as well. So we could run this whenever we wanted to, and suddenly we had a branch with the whole application running onto that core. And this was super useful because we could do that quickly, and we can get a temporary branch that we could deploy and test for different scenarios, and then we could discard it without worrying about merge conflicts. And I call this concept a deferred branch, if that makes sense, because we create a branch on demand, more or less. But this is really useful because you can do like large sweeping changes. You will also learn what you need and not do. And if something doesn't work, all you need to do is just change the tool, and suddenly you have a new version that you can convert. So highly recommend this as well as an approach. And it's not a huge effort to build this tool neither. The tool was probably like 300 lines long at most. But the reason why you can't open source it, even though I would love to, it's not only because of client ownership, but also because it's custom to your app. There are certain things in your app that you have to take height for here, which is why you can't just have a general tool that does this for you. All right, so final part of the web app here is that there are a couple of gotchas as well. So beware of the dog, or the core in this case. When we had our old app, it had a lot of technical depth. So we had stuff that we didn't like, but they worked. So for example, we had a couple of ambiguous endpoints. So it had the same route, but we have different route prefixes. So our application still figured out which was the right one to go with all the time. It's not great, but it worked. But .NET Core does not like that. It hates ambiguous endpoints, and that's awesome. But that caused issues for us for sure to find those and remove them. So that's something to just keep in mind on change behavior. And the same way as well, in ASP.NET Core, or framework, sorry, if you have a view model that you send to your client that are missing certain values, let's say you have a property for a Boolean value. If you don't send that as part of your JSON, the framework will still initialize your view model with that property set to the default value, right? But in .NET Core, that's not going to be the case. It will complain instead, and it will throw an exception. There are ways to go around this. Like what we can do instead is you can create custom serializers. So you can set those default values yourself when you get the incoming JSON. But just be aware that this is a change in the API behavior. And for us, that caused quite a few issues because we have a very large front end. The third thing here is that the controllers in .NET Core is decorated with the API controller attribute, which gives you a lot of magic under the hood. And that's really awesome. But it can have some unintended consequences because it does change the behavior of your controllers as opposed to how they were working in the old framework. And one of the things that it did for us, for example, was that it changed how we validate our model state. So before, the API will still accept the call, even though the model was not valid, because we can check the is model state valid property on the incoming request and do our own custom validation. But if you have the API controller attribute decorated, it will not do that. It will directly bounce before it goes down to your API and say, hey, the model state is invalid. You require this field, and this field is the wrong length, and so forth. And it will do that out of the box. There's a way to remove that behavior. You can suppress that behavior if you want to in the start.cs, but that's something to think about as well if you have custom validations that you want to keep in check. Also, if you're doing Ajax call, make sure you set your content type. Again, this is best practices. This is nothing you should have an issue with, but we had places where we didn't set the Ajax call content type. We didn't serialize it properly. In the old framework, they kind of just worked, but in that core, they're much more strict, which is good, but you will find like this kind of hidden technical depth in your app when you do that. We also had issues with calls from BizTalk. So we here had BizTalk calling our application, making API calls for notifying us of certain events. It didn't work as expected with authentication. We actually had issues with API authentication on the BizTalk side because the 401 negotiation schema did not work as expected. The way to work around that is actually setting impersonation to true on the BizTalk side to get that working. But it took us quite a bit to figure that out. So if you have BizTalk that works with your application, just think of that a bit if you see these kind of issues. The final thing as well is that controllers are not injected as services by default. This may or may not be an issue for you because usually you don't inject controllers into other controllers. But we had some really old code that did that, and you need to explicitly state that in your dependency wire app that you want to inject your controllers as services if you want this to work. All right, a couple minutes left here. So the final piece I want to cover is the CI/CD part, and that's very quickly. Just don't forget your CI/CD. Actually focus on this very early because you will need your CI/CD to test things and deploy it because your deployments will have changed and the way you run tests and build will change. So I think most of you will use MS Build right now if you're on that framework. You will instead need to migrate to the .NET CLI and have like .NET Build, .NET Test, .NET Publish instead. It's a very simple transition, I will say. It's MS Build is very convoluted, a lot of parameters you need to send in. .NET CLI will just kind of work out of the box. So just remember to do this, but this is actually a very easy step and worked really well for us. The second thing here is EF migrations. And I spoke about this very, very loosely before, but we actually decided to have Entity Framework 6.4 to stay in the application, even though the app itself ran on .NET Core. And that works. It works. And again, it's definitely a less risky approach. But you will end up in a kind of a no man's land when it comes to handling migrations and your database state. So instead of having a migrate.exe that you will use for your migrations, you will have to use an ef6.dll instead. And that is kind of a cross-platform version of that app. So you can't, if you end up in this situation, you can't run add migration from Visual Studio anymore. You can't run update database from Visual Studio anymore because Visual Studio won't allow it, actually. The support for that kind of combination is not there. You can, however, create your own PowerShell scripts fairly easily to do this, to run both update database and add database using the ef6.dll. So it's possible, and I'm more than happy to share some of my thoughts and expertise there as well. But just remember that this is definitely a tricky situation, so you don't want to stay here for too long. You want to move over to EF Core if possible, as soon as possible, but just hold off a little bit on it. A final piece here as well is that you do not need to go to Kestrel. And when you talk about the core, Kestrel is usually talked about as well, side by side, as a thing you want to do. And it's definitely awesome. I mean, we can't wait to go to Kestrel. But we actually decided against going to Kestrel right away because of the risk it included. We wanted to do as small changes as possible to make sure we knew what we were doing, and staying on IS was a good enough solution for us. And the reason why is basically because we have Windows authentication. That works with Kestrel too in some aspects, but it's not as straightforward. So that's definitely a risk. And you also have port limitations in Kestrel. So in our case, we host our web apps, multiple web apps on the same VM. And if you use Kestrel, you can't all share the same port 80. So that would have kind of forced us away from having a VM per, that would force us to having a VM per app or something like that. So just be kind of cognizant of that. But if you keep IS, I would just encourage you all to keep the WebDAV module that you have in your web config. It's the only module you really need to keep. And with the WebDAV module, that will allow you to still run the put and delete request to your app. Without it, you may have some issues there that it doesn't understand what a put and delete is. So just keep that in your web config, but that's the only thing you'll need. The final slide here is lessons learned. So what are the things we learned here throughout this year of migrating our app? First of all, unit tests are useless for this part. They're great to test features and they're great overall, of course, but they don't really tell you anything about how your migration is going because they will not test overall functionality of your app to only test certain features. So definitely rely on functional tests instead from the API or from the UI. They will really tell you what's going on here. And the things you will see most of the time is not a functional change. What you will see is like exceptions being thrown in your logs or just strange errors coming from somewhere. So they're both very easy to discover, but you will definitely want to have tests to find them. Again, pre-processor directives are super useful. They will save the day for you. Don't stress to migrate to EF Core directly. You can wait with that. It will save you some time and probably will also reduce your risk. Consider staying on IIS again. We did that. I think that's a good approach, but if you feel comfortable with Kestrel, go ahead and do that. The web app is the hardest part. So definitely allocate a lot of time on this and a lot of thought into doing this, because it will be the most difficult thing, but it is definitely doable. And then the final thing I want to leave you with is that API behavior has changed for your API. So if you have multiple apps that integrate with your app, like we had, just be cognizant of that, because you may break something or someone who's calling you for any reason. All right, we are on time. I will open up the floor for questions, and I hope you have enjoyed and learned something from this talk today. If you have any questions, feel free to unmute yourself or raise your hand or put them in the chat.
So again, another question regarding the continuous function working. With those long migration, especially on the web app part, when you have a enterprise level application with a lot of functionalities, how do you manage just keeping it within a sprint, migrating at the same time, make sure that everything works?
That's a great question. For us, we try to kind of break it down to small segments. So we updated one package at a time, or we approach it one step at a time. We relied a lot on our tests again to make sure it worked. And we also tried to change parts of the code that would be tested by features in the sprint anyway. So functionality that was surfaced by that. So there's different ways you can mitigate that risk by kind of zoning on that. But once you get started, you will quickly kind of see some patterns where you can create tickets for it, and you can update those in isolation. The biggest things, right, that will take a lot of effort is the .NET 4.7.2 switch. That will be like a small bang, if you will. The package updates are not so bad. They can be in a feature for sure, or in a sprint. But the web app, again, is the big thing, and that's why you want to divide up into smaller infrastructure stuff and then the fast changing code into a tool instead. Hope I answered your question, Jeff. I'm not sure.
Well, I kind of understand that just like any other software development, you want to go to incremental on a small portion, but just provided that you're migrating from global ASPX to a startup, which basically does quite a bit of a .NET Core infrastructure change.
Yep.
How do you keep both of them running at the same time? That's what I don't
see. Okay.
understand.
I see. So we actually don't. So we only care about the main .NET Framework one in production. That one has to work all the time. It's fine. When it comes to the web app for .NET Core, what we did again is we created an empty project first for .NET Core, but we did not build it or deploy it anywhere in the beginning. Instead, we created tickets to slowly migrate things over from our old one to our new one. We still kept the old stuff. We kept everything there. We just said, okay, today, this is our empty web app from .NET Core. Today, we're going to focus on setting up authorization authentication. And today, we're going to focus on wiring up our automapper maps. So we, chunked it into smaller pieces so we could do that per sprint, but we did not deliver those to production as part of the release. We were just kind of continually developing those instead, if that's helpful.
Oh, that's a keyword. You're not actually doing it on production. Just,
exactly.
Keeping it local to making sure
exactly
that the core part is working. Great, thank you.
Yeah, because those are the things that no one changes anyway. No one changes global ASACs, at least not very often. The fast changing stuff is the things you want to use a tool for instead. So great.
Right.
And the whole migration took a year, actually. We started in February about last year, and we finished just last week. So that's about how long it took. .NET Standard is a shared framework. So .NET Standard is kind of the commonalities, the common denominators between .NET Framework and .NET Core is going to be in .NET Standard. So if you can target .NET Standard, you definitely want to do that. If you want specific features in .NET Core, then you want to target .NET Core. That helps.
Alex?
All right. Yep.
Yeah. So probably you answered a little bit already, but I had one question. So suppose we have a web API migration to be done, and we have some other kind of other library projects. So as you were saying, like my question is about the strategy. So should we go with the staggered approach, like having both the web API hosted in the production, or again you are saying like you should not go to production unless you are done with the whole migration?
So what we did was we did not go to production until we were done with the whole approach. It depends on your app, but I would recommend that just because you get more confidence from the business and so forth. It does not mean you need to have a big bang because we don't want that, right? We don't want a big bang. But a lot of the things that let's see, a lot of the things that you need to test or update can be done and put to production incrementally, like package updates and dependency updates and targeting new versions and so forth. And the final piece as well here, right? If you use a tool, if you incrementally update the infrastructure and then a tool to automatically update the controllers and views and everything else, you can actually create a branch whenever you want to and run that in non-prod first to get a lot of confidence that your app is working as expected before you go to production. But yeah.
Thank you, Alex.
You're welcome. Again, if you want me to have a look at your apps and kind of give you an idea of how easy it is to migrate over or how difficult and things you want to think about, definitely don't hesitate to reach out to me on either of these contact infos, and I will be happy to do that. We just finished this migration recently, so I have a lot of this knowledge in my head fresh. So I'll be happy to kind of have a quick look and see what it looks like and what challenges you may face and maybe even your strategy that you want to use. And again, it's going to be very dependent on your organization on which strategy you want to use here. Any other questions? Cool. If not, just thank you very much, everyone, for joining in today in this talk. I hope it was helpful. I will speak tomorrow again on MLOps at noon as well. So if you want to get into machine learning, then that's your opportunity. Thank you, everyone.